Good morning to you. Mark Sudduth, HurricaneTrack.com here. Got to talk about Invest 95L here on the morning edition of the Hurricane Outlook and Discussion. It is Friday, October 23rd. Yes, we are at the end of October. Still talking about an active hurricane season. We saw this coming many months ago. We knew that it was going to be a busy season, and so this should be no surprise. I know we're all over it, but we got to deal with it. We have a new system here. Well, it's kind of new. The models have been sort of showing it, and then it wasn't in the models, kind of whatever, you remember. And all of a sudden this morning, we're waking up to, oh my goodness, 50% and 60% chances of development, respectively. And we're talking about this area down here. 50% over the next 48 hours, 60% over the next 5 days for this disturbance west of Jamaica, just south of the Cayman Islands. In fact, let's just read what the Hurricane Center has here. A broad area of low pressure located near Grand Cayman is producing a large area of showers and thunderstorms, mainly east and south of the center. This system has become much better organized since yesterday, and a tropical depression could form during the next couple of days while the low moves slowly towards the northwest. The system is now anticipated to move near western Cuba this weekend and move slowly across the southeastern Gulf of Mexico by early next week. What? I mean, dude, seriously. I mean, this is what the GFS was showing. Remember when it had, like last week sometime, a hurricane developing down here and it moved up across Florida? I'm just saying, that's what it showed, and then it just dropped it. It's like, oh, sorry, I was wrong, my bad. And then now here we have this. I mean, what the heck is going on? And I even saw Eric Blake on Twitter talking about that Genesis this year, the tropical cyclogenesis. There was a little conversation between him and Jack Sillen about the numerical weather prediction, the modeling basically, just not handling the Genesis parameters very well this year. And it's been very challenging, and it continues to be. So let's kind of all keep our cool about it. There's not any indication yet that this is going to blow up into some major catastrophic event. So let's just keep things into perspective. Yes, it is inherently, by the definition, creating a lot of excitement. And I understand that. It's creating a lot of buzz, a lot of talk. And remember, when I use excitement, I do not mean like, oh, it's exciting, we're going to Disney World. That's a different kind of excitement. This is just, I don't know what other, when something's exciting, it doesn't always necessarily mean that it's positive. And in that regard, let's just make sure we kind of keep a level head about it, look at the facts, look at what we know, and then we can examine what we don't know, because obviously there's some things going on in the numeric modeling that's leaving us with these situations where they pop up, at the last minute kind of thing, and we got to deal with it. So here we are. So let's take a look at the satellite vantage point, the wide shot of the Atlantic Basin to start off. And here is our area. Let's use a different color. Maybe we can highlight it all in the color white. Here's our area down here, 95L, another tropical disturbance out here, strong upper level winds. Here's Epsilon. It's well to the east of Bermuda. Now it's pulling away. And those are the major players overall on the wide shot. Looking at a close-up of it here via the weathernerds.org site. These are the first early morning visible satellite images. And you can clearly see by even these limited images, and when I do this later this afternoon, we'll have a lot more, obviously. But the system is located right in here. This is the area of the Cayman Islands. There's Grand Cayman there. And we definitely have low pressure trying to develop, right in here. Strong upward motion down there, thunderstorm activity, high pressure in the upper parts of the atmosphere, way up high at about 200 millibars, and that is what is important. So let's start looking at what we know. Okay, we've kind of addressed, again, this sort of surprise, exciting part of it, so to speak, that something's developed overnight that we weren't thinking of, etc. The models, blah, 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 blah. Well, let's calm down and look at what we know. And that is, we got a low pressure area, we know that, down at the surface. And then above, just looking at the satellite imagery here, you can tell there's anticyclonic flow in the upper atmosphere. And another easy way to look at this, we'll get rid of me for a sec, go back to the satellite animation of the wide shot. The wind is not coming across, gosh, worst colors I could have possibly chosen. The upper level winds are not cutting across this way like out here. You see that? And this is the perfect example of shear. That represents very strong upper level winds. This, the way it just kind of fans out in a clockwise fashion, that shows me that there is anticyclonic flow above this system. And we have the low pressure at the surface. The Hurricane Center mentions that in their outlook. We look at it on the close-up here. You can see broad turning down there. So it's pretty well defined. And then we go over to our next tool in trying to understand everything, the vorticity. And I use this a lot, and this is why. Look at that. It's nice and round, and how many times have I talked about this? You know, that's what you look for. There's another piece of energy down here. Pretty low in latitude, probably runs into South America over time. And then, of course, there's the vorticity fingerprint, as we call it, you know, for epsilon. These are the easy ways to pick out areas of spin in the atmosphere or energy, etc. You know, this vorticity is stretched out over thousands of miles. This is a cold front that's coming. Down in the tropics, when it bundles like that, that's what we look for. So we got all that. Now let's look at sea surface temperatures. I mean, really? Are you kidding me? It could not be located over a better environment for strengthening in terms of water temperatures. Literally sitting right on top of, off the chart, upper ocean heat content. I mean, it's not even, this goes to like a pinkish white, and that's solid white. It's literally, and it doesn't mean that the water's like 500 degrees. Don't get me wrong here. It's not white hot. This is just the gradient, the color scheme, to explain the upper ocean heat content. And that in itself is difficult to try to explain in terms of the physics behind this, because we're talking about energy inside of parcels of water. And instead of getting all complicated, let's just look at the color scale. That's the way I look at it, and explain it as, well, all of this in here, the orange, the red, the white, the pink, etc. That just means very, very formidable upper ocean heat content, which means that the water is warm not just at the skin, you know, the surface of the water, but deep below. That 80-degree line extends down many tens of meters, if not hundreds of meters deep. The water is warm and deep, and so that just churns up more warm water. When you have thunderstorms kind of mixing things up, the wind is blowing across, and it wicks up that water and literally whips it into a fine mist, kind of getting it into the circulation of the system. It's all the dynamics of how a storm works over the ocean, especially these hurricanes, when they become hurricanes, and it just brings up more warm water. That's the bottom line here. So formidable upper ocean heat content all across the region, well entrenched. That's, you know, that's not going anywhere. I mean, it's slowly lessening as we get into the winter months, but for now, it's there. And then, as the Hurricane Center mentions, it's forecast to generally move into the southeast Gulf. Well, most of the southeast Gulf still has decent amounts of upper ocean heat content. It does lessen, but it is there. The northern Gulf, all up here, Louisiana, I know you've been through a lot this year, especially central and western Louisiana, southwest Louisiana. I mean, yes, you can still get a hurricane that cuts across, etc. Sure, I mean, we're not going to be naive and say that that can't happen, but the water temperatures in this part of the Gulf have definitely cooled off, and the risk of major impacts, especially from wind and surge, are greatly diminished. But Florida, no, it is not over yet. Western Cuba, you know, the Caymans is kind of percolating near you right now, so you know it's not over yet. And we have to watch and see what happens. All right, so these are the facts that we know. We have a low pressure area at the surface that's much better organized than it was yesterday. Upper level anticyclone above it, a favorable upper environment. Warm sea surface temperatures, the warmest in the Western Hemisphere. So very formidable in that regard. So seemingly favorable parameters. The vorticity signature that I showed you, it's round, it's nice and bundled there. So it would seem that something's going to try to develop. On top of that, the Hurricane Center has analyzed it, and they look at it and they say in their wording that a tropical depression may form. So we have all of these clues that are suggesting something's going to happen. So now, for what it's worth, what about the guidance? All right? So this is really interesting. Wait until I show you this. I was really surprised when I saw this. And here it is. So this is the operational GFS. This is the GFS operational model. And this is the 850 millibar level, which is the same level of the atmosphere as this, the 850 millibar vorticity. That is what we are seeing right here. Okay, so it's the GFS 850 when the 06Z, the 6Z run. So it's initialized 2 a.m. What are we looking at? Some of you know, most of you know. There's Epsilon as an example, and that's a hurricane in the model. Very easy to see. This is that vorticity I was showing you that stretched out over thousands of miles over the nation's midsection. That's that cold front that's coming. And then this conglomeration of colors and the curved height line down here represents 95L right through here. And you look and you see that does not look anything at all, and specifically look at this area right in here. There's Grand Cayman, there's the western part of Jamaica. So look in this area right here, kind of remember that. And granted, this is initialized at 2 a.m., but it's 7 hours later. But look at this. That is definitely not represented in the model. The reality is that there is more concentrated vorticity or energy down there than the GFS was showing at 6Z. So it's going to be really interesting later today. I'm going to do another update this afternoon when we see these 12Z and if it initialized properly. Very, very interesting to see. So let's just see what happens. All right, let's just go out 48 hours. That's all we're going to look at, and I'll show you why. So we go out to 48 hours. And I'm sorry, I went out to 60, so we'll go to 72. It shows a little bit of a sharpening, if you will, of the overall surface trough down there. Just a little bit of counterclockwise rotation if you look at the wind barbs, etc. It's kind of like, there's something down there. Not much overall. And even in 3 days, 3 days from now, it's still down there, first of all, and the overall vorticity in 3 days still doesn't look like that. I mean, really, the reality is far different. Now, are you ready for your mind to be blown? And before I do that, I need to explain what I'm about to show you. This is the operational current deterministic model of the global forecast system, what we call the operational. Very simple. In parallel to that, Jack Sillen explained this to me very well during a phone conversation in recent weeks. Parallel to this is literally the GFS parallel. And that is the GFS that runs alongside, if you will. That's what parallel means. And the GFS parallel will be the new GFS one day. It's the new version coming along. It's kind of like if you're driving a 2018 Ford F-150, just throwing it out there, and you know that up in Michigan, I guess that's where they make Fords, right? They are making a 2021 version, and you can see them making it. And you go, ooh, those interesting things in there. You understand? Hopefully I'm just trying to make sure you get it. But you are aware that they're making it. You understand? And they're putting features in and they're testing some things. And, well, we may not do this yet. We'll see. But you are aware that they're making that 2021 model of the Ford F-150. And eventually that'll be the one that they put on the showroom floor all across the globe. You understand? But not yet. So that's what the GFS parallel is. It's the new model coming out. It's the new shiny version of a car, if you will, or anything, right? but it's not quite operational because there may be some things they need to tweak and look at, so forth and so on. So that's what the GFSP or parallel is all about. So that being said, this is the operational 6Z. This is the parallel 6Z. All right. So let's just make sure I've got them lined up right. It looks like I do. All right. So good. So initially, just from the get-go, again, GFS parallel, 850 millibars, 6Z, it has a little bit better representation overall of the situation. Wouldn't you agree? Just slightly more orange in there. And I know I'm being nitpicky, but it's important. It does have a better grasp. We got to go back to the initial. Let's compare the two. Let's see. Whoops, hold on. Let me just slow down the analysis. That's what I want. But I want to get these perfectly lined up. There we go. So there's the operational. There is the parallel. I think the parallel has just a slightly better handle on the initial conditions. So let's just move it out to 24 hours. All right? 6, 12, 18, 24. Bingo. Now we'll go to the operational. 6, 12, 18, 24. Yeah. I mean, I would argue, you look at the parallel, I mean, come on. That's the reality now. This is exactly what's happening. This is an analysis from a satellite. So this is reality. This is what the parallel shows. I'm going to have to go with the parallel here. It seems to have a better handle. So 48 hours. Oh, look at that. Now, at this point, do you say, well, the GFS parallel is just amplifying all that. It's got convective feedback problems. It's just going to ramp it up. I don't know. That's the problem. We don't know because this is the future, and the model may be having some what we call convective feedback issues. I don't know. Nobody knows because it's the future. We don't know the future. You know, only Biff Tannen, that's a joke there, knows the future, and Marty McFly, and maybe Doc Brown. But see, hey, that was 30-something years ago. Anyway, for real, we don't know the future. We're trying to figure it out. But it is interesting. You'd have to admit that's 48. Then we go out to 72. Crosses Cuba. It hangs out near the Keys. Parallel at 120. It's up in the Gulf. Why? I mean, a couple of things we can look at. Big old area high pressure over the western Atlantic. Kind of keeping it from going out. That's interesting. That's a huge feature there. Bottom line, ladies and gentlemen, we might have ourselves a player, as they say. We might have something we really have to watch here, as the GFS parallel especially kind of spelling out some very interesting things. But let's just look at it to 48 hours. And because, I mean, everything else just seems to be like, forget it this year. And in 48 hours, there could be a fairly decent storm system approaching parts of south central coastal Cuba. All right, what about the hurricane models? Well, here's the H-Wharf from 6Z. That is a hurricane-specific model, and it's really not having any of it. You see that? It's just like, you don't ever see anything really defined. It goes milling around western Cuba, goes out towards the Bahamas, etc. I mean, and it never drops the pressure below 1,000 millibars from what I can see, right? It's just literally like meh, that word, M-E-H, meh. Now the H-Mon, oh, this is different. The H-Mon deepens it and is very interesting. Goes below 1,000, gets into the low 980s, and then it makes landfall in Florida, in the southeast coast of Florida. So, which one's going to be right? The operational GFS, the parallel, the H-Wharf? What about the H-Mon? Well, if I knew the answer for sure, I'd have a completely different lifestyle, wouldn't I? Because I would literally know the future, and I don't. So I'll just offer this advice. We know it's hurricane season. We know it's very warm out there, water temperature-wise still. It's a favorable pattern and seemingly getting more favorable. I talked about that earlier in the week. The larger pattern suggests a potential strengthening system. So we'll have to watch and be ready. I was thinking about yesterday going to Colorado, and maybe that's what happened. You know how every time I want to leave, if you've been following my stuff, I went to Arizona, and we had a hurricane that hit Texas in July. It's like, daggone. I went to Colorado for a snowstorm. I came back and had to scramble for Sally. In 2018, I went to Arizona for leftovers of Hurricane Rosa from the Pacific. Had to come back and scramble for Hurricane Michael. It's like every time Mark thinks he's going to leave the state of North Carolina, something seems to pop up. Doesn't work that way. It's not like that gives me, godlike powers, and that's not the case. But it is interesting, isn't it? So no, I'm not going to Colorado, obviously. I was thinking about it yesterday. There's the wildfire situation. There's going to be some winter storm action and spilling down into the plains, etc. No, we're not worrying about that right now. My focus will be on 95L and the potential impacts for South Florida. So I got to start getting ready for that, potentially, and whatever that means. Just like you, I'm kind of scrambling to catch up. But the bottom line, we're on top of it now. We have an invest. That's what they call these things when they get organized like this. An invest, an area of investigation. The number is 95. They number them 90 through 99. And the letter L is for Atlantic. So there you go. Beyond that, I guess we'll figure out what happens together. All right? All right. Well, that's it for now. I'll be back, like I said, this afternoon after the 12Z guidance comes out. So later today, 3:30, 4 o'clock, 3 o'clock, somewhere around there, the 3 o'clock hour Eastern time, we'll take a look again, shall we? Very good. As always, thanks for tuning in. I do appreciate it. I am Mark Sudduth, HurricaneTrack.com, and I'll talk to you again in a few hours.